So now let's see what would happen if we multiplied the received input, where we have rewritten it so that the input phase is based on some different frequency, and the VCO output, which has some phase here. So what happens if we mix these two together, multiply these two things together? So we have the received input with some amplitude A and the VCO output with a amplitude B. We multiply them together, and if we remember, there's this product identity. We can apply that product identity, and when we do that, right, we're going to get a whole bunch of these terms here, a bunch of cosines, and we know that that's going to result in some higher frequency terms, and we can already see that here, right, where when we start to simplify these terms, this one has a 2 omega c, so this one's a higher frequency term, but the other one does not. So this is a high frequency term, but this one is a lower frequency one, where it's just based on the difference of these two phases. Now, if we look at the difference between these two phases, right, this is a cosine wave with the difference between the input and the output phase. And if we passed this signal, right, if we put this through a low pass filter, it's going to remove this term, and so we would be left with just this, the difference between the two phases. So if we were left with the difference between these two phases after a low pass filter, this is what our system would look like so far, where this is something that you received some input. This came out of your VCO. You multiply them together, put them through a low pass filter, and you have some signal where it's a sinusoidal signal, and the argument is the difference between the input phase and the output phase.